Hi everyone, and welcome to my video, my YouTube channel on Math Made Easy with Terry in 10 minutes. Okay, Math Made Easy with Terry in 10 minutes. In the previous video, integration of product using integration by part method, we talked about how we got this formula. We talked about the ILATE method and what it stands for. So please. If you've not watched the video, you have to go back and have a look at the video. We talked about this formula. So in order to use integration by parts, you have to, it's going to be integral of u dv is equal to u minus integral of v du. And I told you the function of the ILATE and how to determine which of them is going to be your u and your dv. Okay, so the I is the inverse trigonometry, the L is the logarithm, the A is the algebra, the T is the trigonometry. L is the logarithm, A is the algebra, T is the trigonometry, and E is exponential. All right. And I told you that there are different ways. There are some times you have to integrate once, sometimes you have to integrate twice, sometimes you have to integrate more than once. Okay. Now, in this video, I'm going to just focus on once and twice. Okay. Then the next video, I'm going to talk about a kind of example where you have to integrate several times. Is that okay? So let's say, for instance, number one, we're integrating x squared. Let's say ln x. Okay? That was the example I gave in the last video. Now, and this is a classical case where you have to just integrate once. You'll see what I mean. When you're done integrating once, the answer will just pop up. Does that make sense? It will just pop up here. So what do? The first thing you have to do, remember the formula we're using is integrating u dv is equal to uv minus integrating v du. So the question is, which of them is going to be our u and our dv? So our u and our dv. Okay? So u. We have this is an algebra and this is a log. So x squared is what? We have an algebra and ln is what? A natural logarithm. So if you look at this, the ln, the log comes before the algebra. So that means the ln is going to be our u, then our dv is going to be what? Our x squared. Okay? Now, when we got into u, we need to get our du when differentiate u. And when differentiate ln x is going to give you what? 1 over x. Can you see? And when you, for dv, we need to get our v. So in order to get the v from dv, you have to integrate this. So when you integrate x squared, it's going to give you x3 over 3. And please, if you don't know how to integrate, please go to my previous videos on basic integration. Have a look at that and watch a video that you can come back here, then you can follow up with us. Okay. Now, the next step is now to apply the formula now. So the formula now we are integrating x squared ln x. Okay. Will now be equal to our u is ln x multiplied by what is our v? S cubed over what? 3 minus, we're integrating, what is our v? Is s cubed over 3. And what's our du? Our du is what? 1 over what? X. So this is the same thing as saying, this is the same thing as saying x cubed ln x over 3 minus. Now, this x is going to cancel this. Remain 2 here. We're integrating x squared over what? 3. Now, the next thing is that we're going to bring the constant out. So we're going to have x cubed ln x over 3 minus 1 over 3 ln x squared. Okay? Now we're done. We integrate x squared now. So it will now be equal to x cubed ln x all over 3 minus 1 over 3 Now, when you integrate x squared, it's going to give you x cubed over 3 plus c, okay? And that will give you x cubed ln x over 3 minus, you open the bracket, and that will give you x cubed over 9 plus c, okay? Now you can collect like terms, and that will give you x cubed over 3. It will now give you, we're left with what? Ln x minus 1 over 9. No, sorry, this is 3. So it's going to be 1 over 3 plus c, and that's the answer for that. So when you integrate, okay, so when you integrate x squared, product of x squared and ln x, the answer you're going to get is x cubed over 3 into bracket ln x minus 1 over 3 plus c. Okay, so let's solve another question, okay? All right, so I'm going to just write the formula again just to remind us. So the reminder again is square root integral of u dv is equal to uv minus integral of v du. And also, you need to take note of what? The highlight what? Method. You take note of the highlight method, okay? So, let's see what we can do. Let's pick another question now. Let's see what question I'll pick here. So, let me see. Let's pick something on 2x squared. Let's say we're integrating x squared e maybe 3x. Okay. Now in this example, so if you look at the previous one I just solved now, okay, you look at this previous one, we only integrated once here. Does that make sense? We didn't integrate more than once. Okay. But in this example I'm going to solve, you see that we're going to integrate twice. You see that we're going to integrate twice by parts. Okay? There, we just integrated once by part. But in this example, we're going to integrate twice. All right? So let's start now and see. Now, we have this. So as usual, we need to know which is the u and which is the dv. Is that okay? So the u we're looking for, and we're looking for what? The dv. Now the u, so now we have algebra and exponential. So we have algebra and exponential. So therefore, our algebra is going to be the u, and our exponential is going to be the what? Dv. So we have u to be x squared. So we can now find that du, when differentiated, is going to give you what? 2x. Is this making sense? Now we have this. We're going to integrate from dv back to v. And if you integrate e3x, it's going to give you e3x divided by what? 3. We're done. Now go back to the formula. So when we're integrating this, so we're integrating x squared dot e3x will be equal to our u, which is x squared, multiplied by our v, which is e3x divided by 3, okay? Minus, we're integrating v, and our v is e3x divided by 3, and our du is 2x. Is this making sense? So what I'm going to do is going to be x squared dot e3x divided by 3 minus, I'll bring out the constant here, and I'll give you 1 over 3. We integrate e3x dot 2x. Can you see? Now we are back, we have another product here, and we have to integrate the second time by parts. Can you see? We're integrating the second time. If you look at the previous video, we only integrated by parts once here. Okay? And then we now did the normal integration. Here, we're going to integrate by parts twice before we now start with normal integration. So now, we're having the same problem here, we're having two products. We have an exponential, and as well as that, we're also having an algebra, okay? So exponential and algebra. So that means in this case here, I'm going to write it here. Our u is going to be 2x. Can you see? Our exponential and algebra. So our u is going to be what? 2x. And our dv is going to be exponential what? 3x. Then our du, when you differentiate it, is going to give you 2. And when you integrate this, it's going to give you exponential 3x divided by what? 3. Okay. So now we're going to apply this concept into the equation again. So that will give you, so that this is the second time now. So x squared e 3x over 3 minus 1 over 3 into bracket. Now we're going to start. Remember the formula? The formula is uv, right? So our u is 2x multiplied by our v is e 3x over 3. E 3x over what? 3. Can you see? Then we've gotten this minus the integral of v. What's our v? Our v is exponential 3x over 3, and our du is equal to 2. Are you seeing it? Then we move to the next part. Okay? So we have x squared dot e 3x over 3 minus 1 over 3. So I can clean this part on the board now, okay? We've used it already. So this is the second part. Or is it possible for me to highlight it and drag it somewhere else? Let me see if I can do that. Yeah, so drag it down here. Okay, so I can keep solving. So 1 over 3 into bracket, 2x e 3x over 3 minus integrating 2 e 3x over what? 3. So then I'm going to bring the constant outside. So that will give me x squared dot e 3x over 3 minus 1 over 3 into bracket 2x e 3x over 3 minus 2 over 3 integrating e 3x. Can you see? Now, when you integrate e 3x, it's going to give you x squared dot e 3x over 3 minus 1 over 3, 2 over 3 x e 3x minus 2 over 3 dot e 3x all over what? 3. Is that making sense? So you see that we've integrated it now. So now, lack of space, I'm going to go to the next page. Let's see. Or maybe I will just delete this one so I can finish solving it here, okay? So then this is going to give us x squared dot e 3x over 3, okay, minus 1 over 3 into bracket 2 over 3 x e 3x minus 2e 3x over 9. Are you seeing it? Can you see? Then I can open the bracket and I say x squared dot e 3x over 3 minus 2x. So I'm going to open, multiply 1 over 3 with this. So it'll be 2x e 3x over 9. Can you see? Or better still than doing that, I can just collect like terms here. All right. So it will be easier. Okay. Let's collect like terms here. So what is the like terms here? So we have 2 is common and e3x is common. So, and 3 as well is common here. So I can say this is going to be 2x, 2e. Let me do it this way. No, some of you will be confused. Okay. Let me do it this way. Let me just open the bracket. So it's going to be 2x e 3x all over 9 plus minus 1 over 3 times this, okay? It's going to give you plus 2 e 3x over what? 27. All right, over 27. Okay, so I'm going to clean this part so that I can see the question here. So continue solving it. So I'm going to clean this part here so you can continue solving. So and this is going to give us I appreciate that this is going to be a little bit long, but it's the same thing. Now if you look at this, what is common here in all of them? So you're going to have, so I can have x squared dot e 3x over 3. Now, what is common between these two here? Okay, so it's minus 2 over 9 e 3x, can you see? And we're left with x minus 1 over 3, like this. Can you see? Also, I can simplify between these two. I can also say e x or e3x over 3, and I'm now left with x squared minus e3x over 3. It will now give me 2 over 3. Can you see? Into brackets, x minus 1 over 3, x plus c. And that is the answer for that. Okay, and that is that for that. Okay, so I'm going to stop here. Okay, so that's how you integrate. You see, in this example, we integrated twice, while in this example, we just integrated what? Once. Is that okay? So that is that for that. So the next video, I'm going to talk about how do you integrate when you have questions like you have to integrate more than once. And one of the classical examples is integrating e 3x sine x. Okay, we're going to talk about this. In this part, you can see that you're going to keep on integrating till infinity. And how are you going to solve that? Okay. All right, I'm going to stop here. I think I've gone a little bit over 10 minutes. All right. Okay, I've gone a little bit over 10 minutes. So I'm going to stop here and I'll see you in the next video. Thank you very much.